So in the last class, we have finished inner shell is earth and charge is given to outer shell. Now one more note point. We have two shells. This first one and this is second one. Again we will earth this inner shell, something like this. This is A and this yellow shell is having radius B, and we are taking one point P here, whose radius is, let us suppose, R. Like this. And now charge is given to this outer shell. So this arrangement is not a capacitor. This arrangement is not a capacitor, but capacitance is equivalent to the sum of capacitance C1 for spherical capacitor and C2 of spherical conductor. Now C1 क्या है? Yesterday we have learned 4 pi epsilon naught AB by B minus A. This we have learned in the case 1. You can see in your notebook, previous case is this only, and C2 is just a spherical capacitor whose radius is B. So this is nothing but 4 pi epsilon naught B, and this C is equal to C1 plus C2, which is equal to 4 pi epsilon naught AB by B minus A plus 4 pi epsilon naught into B. Yes. And if we will add them, what we will get? 4 pi epsilon naught B square divided by B minus A, which is same like your second case. Yes. So this structure is also having the capacitance which is like your second case. Understood? You note down karo. Next one, that is cylindrical capacitor. If you have cylindrical capacitor, something like this, You can see here, this is what cylindrical capacitor. Its radius is A and this radius is B and charge given is Q, whereas its length, if it is L, then the capacitance is given by 2 pi epsilon naught L divided by log to the base E B by A. This is for cylindrical capacitor. Okay, note down this fast. We will go for nodal analysis. Note down fast. Let's move ahead. And the new topic, that is nodal analysis. So first of all, we have to follow the steps in problem solving. So see, first of all, steps. Step number 1 to follow. Assign a node as a reference and assume its potential to be 0 and assume its potential to be 0. Yes, that is step 1. So what we have to do? We have to assign a node as a reference and assume its potential to be 0. That is what your first step. Step 2. Step 2. What we have to do? Assign the potential of every junction of the circuit what we have to do? We have to assign the potential of every junction. Okay. Assign the potential of every junction of the circuit as an unknown let us suppose yes. Next step 3. Step 3. Apply Kirchhoff's current law. Apply Kirchhoff's current law at the junction corresponding to unknown potential. Corresponding to the unknown potential. Okay, next one and last one. Step 4. Solve equations to find unknown potentials. To find unknown potentials. Now you will ask me question, why we are going to use this nodal analysis? What is the use? Okay, right. So what is the use of this? Okay. So first of all, the use of this is we can find the charge on any capacitor used to find charge on any capacitor. Okay, and this method is based on conservation of charge principle. Conservation of charge. Got it? On which it is based? On conservation of charge. Okay. Understand? Right? So first note down this, then we will see one example, then you will understand nicely. This is just the steps. It is like free body diagram. You know, no? When we are drawing free body diagram, how we have to follow some steps. Like that only. For nodal analysis also, we have to follow some steps. That is what this. Clear? So first note down this. So finished everyone. So let's move ahead. And now one example I'm taking here. So see how we are going to apply this nodal analysis. Let's see one example. Okay. So you can see in the diagram, we have how many capacitors? 1, 2, 3, 4, and 5. Okay, na? How many capacitors? 5 capacitors. This is battery, so it is 10 volt, minus and plus here. This is another battery whose potential is 5 volt, and here one more battery whose potential is 10 volt. And now this one is 2 microfarad. This is 4 microfarad. This one is 4 microfarad. This one is 2 microfarad. Again here it is 2 microfarad. Okay, right. Now let's identify the nodes. So what I'm doing, I'm assuming some nodes. So see here, how many nodes I am having. This is 1, 2, 3, 4, 5, 6, 7, and 8. Like this nodes I am having. Yes, no? Right? Clear? So what we have to do? Assign a node as a reference node and assume its potential to be 0. Okay. And then, so let us assume that I am assuming here as a 0 volt. This is 0 volt. So this will also become 0 volt. Yes, no? Right? Now here it is plus and minus. So here you will get plus 10 volt. Here you will get plus 10 volt. This is what here? This is plus 5 volt at this node. Then this plus 5 plus this 10, you will get here how much? Plus 15 volt. Yes, no? These two cells are in series and this is common point. So here you are getting plus 15 volt. Same wire is going here. So here also you will get plus 15 volt only. Now these two nodes, I am assuming that it has a X and Y, means potential at this node has a X and Y. Now how to use the nodal analysis here? Here we have assumed 0, then according to the battery conditions or battery connections particularly, we got some potentials here, and those two nodes which I have denoted as a X and Y, that are unknown potentials which we have to find first. Yes, no? Clear? Now, what to do? See, here, what I am doing, you see, this 2 microfarad capacitor is there, no? 2 microfarad capacitor. I am assuming that the charge on that capacitor is Q1. What is the charge? Q1. On this it is Q2. Okay. And on this it is Q3. Right? And on this capacitor it is Q4. On this capacitor it is Q6. Is that clear? Q4 or Q5, not Q6. We will make it as a Q5, not Q6. So this is Q5. Right. Now how to find Q1? See, now Q is equal to, we know formula, C into V, but here C into delta V. Why? Because it is nodal analysis. No, so this point and this point we have to take into consideration. And always the unknown one is there now. We have to assume that that is higher potential. So therefore, Q1 is equal to this capacitor, that is 2 into delta V, means what? X minus 10. Is that clear? Understand this part? Is that clear for this part, or the charge through this branch? Understood? X minus 10 into 2. that is 2 into delta V. Is that clear? Good. Now, similarly, I want for this also, I am changing the color. You see, for this branch also, I want the charge. So similarly, I am doing like this. Q2 is equal to 4 into x minus y, because this is only higher potential which we have considered. That's why 4 into x minus y. Clear? Right? Similarly, let's move ahead. I'm changing again color. Let's take which one should I take? Yellow I will take. Now this branch, you see, this Q3, that is Q3 is equal to, tell me, 4 into y minus 15. The one which is unknown, we have to assume that as a higher potential. Okay. Next, Q4. For that I'm using white color, this branch. Okay. So what you are getting, Q4 is equal to 2 into x minus 0. Check it. Is that clear? So that is equal to 2x. Yes, no? Understanding, please tell me. Next again, this branch, you have Q5. So this Q5 is equal to 2 into, tell me what you will get, right? Y minus 5. Yes, no? Yes, good. Understand? Clear? Understood? Any doubt, please ask. So like that, just Q is equal to C into delta V we have to do, and unknown potential should be higher. Okay, right. Now, what I'm going to do now, see. Now, at X, listen here, at X, at junction X, summation of Qi is equal to 0, and therefore I'm adding all these at junction X. What you have? Q1 plus Q2 plus Q4 is equal to 0, and therefore Q1 value is what? Tell me first. 2 into x minus 10 plus Q2 value 4 into x minus y plus Q4 is there, hai? So 2x is equal to 0. Check this. Did you understand? Did you understand? Yes, no? And therefore, from this only, 2x minus 20 plus 4x minus 4y plus 2x is equal to 0. This 2 plus 4 plus 2, 8x minus 4y is equal to 20. Yes. And if I will divide with 2, I am getting 4x minus 2y is equal to 10. Yes, no? Again, can I divide with 2? So I am getting 2x minus y is equal to 5. Is that clear? I got one equation from this. Understood? Understood or not? Call this equation number 1. Clear? Yes or no? Clear? Please tell me if you have any doubt. Just at that junction, whatever the charges are there, you have to just add them. Clear? Note down fast. So let's move ahead. Yes. Now we got this equation at this junction X, we can say. Similarly at Y, what I am doing, at Y I am doing. What is there? Q2, Q3 and Q5. Yes, no? Q2, Q3 and Q5. Now you see here at this junction, initially we have assumed that X is what? At higher potential. Yes, no? But now when we are iterating with this, we have to assume that this is higher potential. So what we are getting? Minus Q2 value, what we have? Q2 value, what we have? Minus 4 into X minus Y. Why I have taken minus sign here? Actually, it is what? 4 into Y minus X. Yes, no? We can write like that also, no problem. You write like this. Whatever we have, 4 into Y minus X. Why here Y minus X? Because now here this potential should be higher potential. That's why 4Y into Y minus X. And in this case, Q2 is equal to 4 into Y minus X. So that is equal to minus 4 into X minus Y. This is what? The direction matters. And that's why I can write this Q2 like this also. That is minus 4 into X minus Y plus this Q3. Q3 is what we have as it is 4 into Y minus 15, because here only a one unknown node is there, plus Q5. Q5 is what we have? Q5. Q5 is what? Yes. Four into Y minus 15. Two into Y minus 5. Plus 2 into Y minus 5 is equal to 0. Check it once. Q5. 2 into Y minus 5. Right or wrong? Yes or no? Check it once. Is that clear? Check it once. So minus 4x minus plus 4y plus 4y. Okay. Minus 60. Check karo. Plus 2y minus 10 is equal to 0. So here I am getting minus 4x. 1, 2, and 3. So minus 4x plus 10y minus 70 is equal to 0. Check it once, everyone check karo. So minus 4x plus 10y is equal to 7. Yes. Yes, no. Check karo. Is it correct? So minus x. We can't divide with 4, no? Okay. We will divide with 2. Then what we are getting? Check it. Minus 2x plus 5y is equal to 35. Call this equation number 2. Initially what we have? 2x minus y we have. So adding equation 1 and 2. Adding equation 1 and 2. What we have equation 1? 2x minus y is equal to 5. 2x minus y is equal to 5. Yes, no? And minus 2x plus 5y is equal to 35. This will get cancelled. 4y is equal to 40. Y is equal to 10 volt. Yes. Y is equal to 10 volt we are getting. Yes, no? एक बार check करो रे. X is equal to, okay, y is equal to 10. Check करो एक बार. Is it right? Check करो. And if we will substitute y is equal to 10, so 2x minus y is equal to 5. So 2x minus 10 is equal to 5. So 2x is equal to 15. X is equal to 7.5 volt. Clear? Yes, no? Check करो एक बार check करो, सब कुछ सही है, right? And now let's find out charge. Let's find out charge. Therefore Q1 is equal to, what is Q1 value? 2 into x minus 10. 2 into x 7.5. Okay. Minus 10 into 10 to the power minus 6. Why? Because this is in microfarad, no? That's why I have converted into farad. How much you are getting this? Tell me. 5, how much? Minus 5 microcoulomb, coulomb. Okay, microcoulomb. Right. So you are getting here 5 microcoulomb. Q2 क्या आ रहा है? Q2 देखो. Q2 क्या है? 4 into x minus y. 4 into 10 to the power minus 6 into x minus y, na? So minus 2.5. Is it coming minus? This is also, I think, minus only, na? Yes, no? X minus y. So minus 2.5. How much you are getting here? Yes, check it. How much this is? Minus 10, huh? Minus 10 microcoulomb. Okay. Next, Q3. Q3 is equal to what, ray? 4 into y minus 15. 4 into 10 minus 15. So what is the case? Bolo? Minus 5 into 10 to the power minus 6 is there. So how much this is? 20, minus 20 microcoulomb. Yes, no? Q4. Check करो रे, check करो everyone. Next Q4 देखो. Q4 is what? 2x है. 2x means 2 into 7.5 into 10 to the power minus 6. That is equal to 15 microcoulomb. Yes, no. And last one Q5. 2 into y minus 5. 2 into y minus 5. So this is 2 into 10 to the power minus 6 into y. 10 minus 5, that is 5. So this is 10 microcoulomb. Check karo. Is it correct? Check it once. So आपको 3 चार्जेस जो है माइनस आ रहे हैं. So according to that you can find out the flow of charge also. Okay. Is that clear? Any doubt? Understand this nodal analysis? Clear? Note down. Yes. So we will stop here. I will upload this video on YouTube. Okay.